Alright. Alrighty, so as it tells us in the book here, for some reactions it is not possible to determine the heat of reaction using a calorimeter. An example, the partial combustion of methane. Very hard to find out for the partial combustion because it's so, it has such a great tendency to completely combust. And so what Hess's law is saying is that it doesn't matter what route was taken. All we need to know is where we started and where we finished. Okay, so we need to know the beginning and end. And it doesn't really matter what reaction process we took to get from the beginning to the end. We're going to be able to use the difference to calculate the difference in enthalpy. The analogy here is that you want to drive from Burnie to Hobart. You could go via the Bass Highway or the Midlands Highway, the West Coast. You could go any way you like. But you've started in Burnie and you've ended up in Hobart. And so that difference is what we need to focus on. Right, now Hess's law can be quite complex. Because we've got to think about the arrangements of the equations that are given to us in the questions. We have to select the relevant equations and remember about the change of phase. So if it's a gas or a liquid or a solid, it has to be the same as what you're trying to achieve with your reaction pathway as the ones that you're selecting. And we might need to multiply and we might need to reverse. So this is why it's a little bit complicated. Our first example is the delta H, change in enthalpy for the formation of ethane. So we've got 2 carbons as graphite, plus 3 hydrogen gases, giving us ethane. And we're given the following equations. So we've got C as graphite, plus oxygen, giving us carbon dioxide. We're also told the change in enthalpy for that reaction, minus 393.5 kilojoules per mole. The second reaction we're given is hydrogen gas plus a half oxygen gas, giving us water as liquid. And then our third equation so this is what we want to end up with, and these are the 3 reactions that we need to be able to use to get there. Now the first thing I like to do is identify my reactants. So here I can see that graphite in my first equation matches up with a reactant in the equation that I'm trying to formulate. It's not identical though, is it? At the moment, I've only got 1 carbon in my given equation and I need 2 for this equation. So I'm going to start out by trying multiplying this equation by 2. So I'll end up with 2 carbons as graphite plus 2 oxygens, and it's going to give me 2 carbon dioxides. It's also going to double this. It's going to give 2 times minus 393.5 kilojoules. Yeah, and so that's one thing that I've got. I know also that now I've got a product that I'm not going to want, but I'm going to focus in, and I'm just going to use a different colour. Hopefully you can see the purple, because I want to have a product that makes sense as well. I need to make my ethane, and I've got that here, don't I? But that's on the wrong side, because here it's a reactant, but in the equation I'm trying to make, it's a product. So I need to reverse this one. And I can express that by saying I'm multiplying by -1. Okay? So I'm going to write that out flipped around the other way. I'm going to have 3H2O liquid plus 2 CO2 gas, and that's going to give me ethane C2H6 gas plus 7On2O2 gas. Now because I've flipped it, I have to also change the sign over here. So that's going to be a positive 1560 kilojoules per mole now. Alright, so let's have a look and see how we're going. Well, something good has happened for us in that we've got, these are cancelling out now. If I combine these two together, they cancel out. And I need some hydrogens. I haven't got hydrogens in my final equation yet. So I need 3 hydrogens. I might just change the colour again. I'm just using colour because it can get a bit confusing. Let's see how the orange goes. Okay, so there's the hydrogen there, and I'm trying to match it up with this one. And so I reckon I should multiply that one by 3 so that I've got 3 hydrogens. So let's have a look and see what happens. I don't think I can write with that one, actually. I'll just write that one in black. 3H2 gas plus. Now, what's 3 times a half? 3 on 2. What's 3 on 2? 3 on 2 is actually equal to 1.5. So, see, this is where our fractions that we probably learnt in primary school are really useful. So if I were to multiply this by 3, it's actually going to be 7 on 2. Because 3 times 2 is 6 plus 1. Okay, 7 on 2 oxygens. Is that all right? No?
You'd need 3 on 2 because you've got O2 in the first equation that you multiplied by 2 there.
I'm just multiplying this by 3.
Yeah.
So you'll have 3 on 2 still, because the other equation that you did at the start with the graphite, you'll have 4 on 2 there, and those two will add up to having 7 on 2.
Okay. Yeah, okay, yeah, you're right. 3 on 2. Okay, good. I'm glad someone's paying attention. You're right, I am just multiplying that by 3. So the 3H2O. Liquid. And yes, this is now 4 on 2. which will add up to 7 on 2, and so they can cancel out. And our waters cancel out. Now what I haven't done yet is I haven't multiplied this by 3. But what remains is, I think it all matches now, doesn't it? We've got the 2 graphites and we've got the 3 hydrogens giving us the 3 methanes. Now, we do need to do the maths part then over here to work out the total for the reaction. Is that okay, or is that not really?
Yeah, that's good.
Do we want to do the second example? Yeah, we'll just quickly do the second example. Oh, don't worry, I think you can do the maths part. It's just adding them all together. Hopefully you can do the maths part better than I did. These examples are actually on the easy side. Some of them get quite difficult, especially if there are changes of phase. Alright, so same deal. We want to do a half nitrogen gas plus oxygen gas, giving us nitrogen dioxide gas, and we're given N2 gas plus O2 gas, giving us 2NO, nitrogen monoxide, delta H 180.5 kilojoules. We should only say kilojoules per mole when we have a mole as well, otherwise our units should be just kilojoules. Gas plus O2 gas goes to 2NO2 gas. Delta H equals minus 194.14 kilojoules. Alright. Same thing as before, identify ones that match up. So the nitrogens obviously match here and here. But in an equation we're trying to make, it's half the mole, so we can multiply this by a half. And we want nitrogen dioxide as our product, which we have here. So that looks like it's also right. We also want half of this one, because we've got 2 nitrogen dioxide, so we only have 1 in our given equation, so we need to halve that one as well. So if we do our first reaction in red, it's going to be a half N2 gas plus a half O2 gas, giving us NO gas, and our delta H will equal a half times 180.50 kilojoules. And then our second one is just going to be NO gas plus a half O2 gas, gives us NO2 gas. We're going to multiply that by a half as well. That's 114.94 kilojoules. And then these cancel out. Our nitrogen monoxide cancel out. And then these add together to give us O2. So that's worked out. And we then just need to add these together to find out the change in enthalpy, which according to the book will give us 33.18 kilojoules. But I do strongly recommend colour is helpful so that you don't lose track of where you're at, especially when you've got multiple of half equations. And writing them out. Don't try and do it all in one go up here. Like, even though I've written those instructions up there, to make sure it works, you really need to write them out.